Here we are going to discuss about moving boundary work. Moving boundary work is associated with a closed system. For an example, here I have given you piston and cylinder device which is expanded. You can say that I have selected a boundary around the gas volume, and when the gas is expanded, the volume of the boundary is increased. So the boundary moves. When you move the boundary, you may do some work. So that work is called as moving boundary work, and it is denoted by WB. The easiest definition for work is this. Let's say that you have a force which is used to push a heavy load against the friction. And if you move that force F through a distance of S, the work done is defined as F into S. This is actually how you define the joule. 1 joule is equal to force of 1 Newton into distance of 1 meter. We all know that pressure is equal to force divided by area. So we can use that relationship to calculate the force required to move a piston. So let's say the pressure inside the piston is P and the area of the piston is A. So we can easily deduce that the force that we need to move the piston is equal to A into P. Now if we want to calculate the incremental amount of work that is done when we move the piston for a distance of ds, incremental distance, we can write this equation. Delta WB is equal to force and ds, distance traveled. So here WB stands for boundary work. Now I told you that F is equal to PA, so we can write this equation. And also you can say that A into ds gives you the change of volume. So we write it as dV. So that is why delta WB can be written as PdV. If you want to calculate the total amount of boundary work, you can integrate this from state 1 to state 2. So it gives you WB is equal to integration from 1 to 2 PdV. Because WB is written as PdV, we call it as PdV work. Another term that you are going to come across throughout this lecture is quasi-equilibrium process. Quasi-equilibrium process is a process where equilibrium is maintained all the time. It is also worth to remember that WB is positive when it is an expansion and WB is negative when it is a compression. We are going to discuss this using our sign conventions later on this lecture.